So, welcome everybody. Kind of a weird sensation standing up here and just seeing you with headphones on. Welcome to our talk, Zero Downtime Development, um, because you are the mission critical resource, a talk from developers for developers specifically. And before we dive in, we'd like to give you a quick introduction for ourselves. I'm Jürgen Albert. I'm the founder of Data in Motion, founded the company in 2010. We are situated in Jena in Germany, in the middle of Germany. We mostly do consulting, research and development, concrete development, and training around complex distributed and modular systems. And have some real-life experience with medical systems, with transportation traffic, public sensors, smart city, and stuff like that. So whoever wants to stick around can hear us afterwards with pure smart city talk. And with that, Tim, you can introduce yourself.
So hi, I'm Tim Ward. I'm the CTO at Kentyou. We're a small company located in Grenoble in France. We do product development, we do R&D activities, and I personally have a lot of experience with large event-based systems, particularly distributed data. And as a company, we do a lot with data analysis, visualization, some machine learning with the data streams that we have as well, and particular focus on traffic management and energy domains. So what we're here to talk to you today is about development and projects, and we thought we'd start with a little discussion about microservices. So microservices have been around for a really long time at this point. They got popular and sexy in the early 2010s. There was a set of posts, blog posts, books, all talking about how really what you wanted was something kind of containerized, maybe using Docker, although Docker was pretty new at that point. And you were trying to make small pieces of business logic that ran independently, and REST was the way with which we were supposed to talk to absolutely everything. And the goal was about trying to get your code and package it into a small unit that was decoupled and therefore easier to maintain. So the individual parts of the team, they can focus on the microservice or microservices that they're responsible for and not have to worry about the application as a whole. And they get to choose what they want to use to write their particular microservice. So if you want to do it in TypeScript, great. If you want to do it in Rust, great. If you want to do it in Lisp, then knock yourself out. So the overall picture looks something like this. You have your containers, and they consume and provide services, and they talk to each other through those services, and what's inside those containers cannot get out. That's the idea. You have encapsulation of everything that is in there. So how does that really apply with modularity? Well, modularity has a very similar picture. We have these modules communicating with services, and we've chosen a different icon because these things might or might not be containers. You can view containers as units of modularity, or you can have modules that are smaller than containers. But fundamentally, it's the same picture, whether we're talking about REST microservices in containers or microservice at any other level. So in your modular system, you end up with, this is still a relatively simple system, but you can see very quickly you can end up with what is relatively spaghettified. You have dependencies between different modules and different groups of modules, and you look at them and there can be quite a tangle. If you're lucky, you'll be able to maybe draw some boxes around them and say, oh, we have these groups of microservices that we can then sort of aggregate. But overall, the system can look quite messy and can be hard to reason about. And the problem we've got is that distributed systems are just inherently hard. There is no easy way to deal with distributed systems. There are tools that can help us, but then they can't abstract away the problem entirely. If you are remote, there will be failures that you don't expect. If you are remote, things will be slower. If you are remote, side effects will be different. And you have this huge battle to keep the system consistent over time. So you have something that initially looks like this, but as someone upgrades it or as parts of it evolve, the picture will change. And it's really difficult to make sure that your overall view of what you're deploying is in sync with reality. So if you want to run a system like this, you need your DevOps team to be really on it. They need to understand what they're doing, they need to understand what they're deploying, and they need to have really good monitoring to be able to tell that all the pieces are healthy and working as they should. And the issue we have is that because you need a great DevOps team in order to make this work, the developers tend to rely on the fact that they've got a great DevOps team to fix problems that they themselves have created. So if they have lifecycle problems in their application, they will say that it is the ops team's job to fix that by making sure that the application starts up in a particular way. So fairly quickly, the view of microservices became this. You had your one great module that it was your monolithic thing that everyone loved, and then you split it into a whole bunch of modules that were smaller but otherwise exactly the same. And very quickly, it went from, oh, is this really how microservices are, to everybody agreed. Everybody wanted this T-shirt because it was exactly how they felt about microservices after about 5 years. We are now more than a decade later, and we've had this decade of improving technology. So automated builds are far better than they ever were. We've moved through simply having a build server that would build our code through to continuous integration, where every commit that we push triggers a build. The continuous testing, so automated testing that we'd begun to work on, has been improved. Its coverage is wider. We're now not just doing unit testing, we're doing integration testing, we're doing system testing, and we're doing that every single time that we push a commit. And then what we're doing is, if everything looks okay, if we've passed through all of those testing hoops, we're able to do continuous deployment. So not only is it built and tested, every single commit can be deployed to a testing server so we can see what it behaves like in the real world. So everybody wants this, right? This is the gold standard of how you deal with your code. And you want your automated micro releases where you merge your pull request and everything will run through, be deployed to your testing environment. You'll say, great, you'll click a button, it will create a Git tag, and it will push it to production. And part of what has made this easier, and part of what's made this possible, is the amount that we can now run in Docker. So we've gone from this situation when microservices were just starting, where Docker was this cool toy that people were playing with, but wasn't necessarily that widely used or that well featured or had that many tools, to now Docker is available and something that you can use easily from just about any platform anytime you want, with tooling that will lint your Docker files, that will build things for you, will push things for you, and the whole ecosystem is really very much more focused around Docker. So you end up with this situation now where living with microservices isn't that horrendous situation that it was. It's become really easy to write microservices. You have annotations that will create these things, that will push them, that will make sure that they're automatically documented and published. The development tooling is there to actually make this an easy experience. Testing suites, testing frameworks are available, and because you have smaller microservices, the whole build, test, run cycle is much shorter. The problem is that we still haven't fixed the fundamental issues that we had, which is that developers think statically about their code. They don't think about, they think maybe dynamic at startup. How do I make sure I've got all the pieces I need? But once something's started up, they kind of expect that it will stay that way forever. And it's simply not the case in a modular microservice environment. We have startup issues if things don't come up in the order you expect. We have odd failure modes when things fail over. You can try and get Kubernetes to fix it for you by having some kind of dependency set up or some way of waiting and some level of failover. But it's a clunky experience and it doesn't always work. It's also the case that if you split a large monolith into lots of small pieces, and you don't at the same time refactor and improve, that what you've done is you've taken one large bad piece of code and given yourself many smaller bad pieces of code. It's not actually any better than it used to be. And if we want to do all of this work in our IDE support for this hasn't improved at the same rate that everything else has. The debug cycle is still not as nice as it could be. So dynamic life cycles, which I've been talking about, are one of the things that's causing us problems. And it's because in reality, we think of our modular system as static, but it's not. The modules themselves have a life cycle. They start up, they potentially go wrong, they get shut down, they get updated independently of each other. And the services that they provide can also come and go independently of the module. The module may still be running, but the service that it provides may become unavailable because something else is going on. Maybe a dependency that it has is no longer available, so it cannot provide its service. And this leads us to, as I've mentioned, this situation where hopefully you can draw some boxes around what it is you've been deploying. So we have the modules that we want to work with, and we have the containers that we put around these groups of modules in an effort to try and control some level of dynamism. But we've still got this issue around container lifecycle, application lifecycle, module lifecycle, none of which are exactly the same thing, and they do change independently. So all of our modules have to be aware of what's happening. And what we really need is we need this way to be able to shift modules between containers and understand how that's going to affect the lifecycle of our system. So now we need to see how we can make life better. And for that, I'm going to hand over to Jürgen.
Thank you very much. Yeah, in order to make life better, we need to understand one fundamental thing that Tim was already talking about. To quote Peter Green's thing up here, modularity is hard. So it's a way you need to change the way you think about things. And if a developer changes to a more modular system, they need to understand and learn gradually what this means. So what does it mean in terms of life cycle, what it means in terms of when I do a change, what's the result of this change, how does it react and interact with the overall system. I might not even fully comprehend and see around that. And for that, it would be great to have a tool which could take us by the hand a little bit and gradually supports us and teaches us all these things. And a tool and also a system which provides all these things that you can build your modules in one place and then gradually distribute them or move them around in different systems. So, and yeah, that's basically what we want to show you. Before I forgot that I have another slide in here. So how should such tooling look like? So the one thing is, like I said, you directly need to see the impact your actions have. You need to see it in the moment you press save, that something happens in your system. And what's the result of that? What happens? You need a tool or a system which can handle different versions. You can handle different modules and helps you assemble them and helps you taking care of the versions and when things change, how to, it gives you suggestions and takes you a little bit by the hand. And easily helps you to move things around inside your thing. And then in the overall scheme of things, you need a system where you can distribute your stuff and orchestrate it and make sure that when you have a service and a new service is there, that it is discoverable and somebody can see it and can interact and read the whole thing. So luckily, something like this is around, and I'd like to show you how this looks. So we go here. We do the whole thing with a little bit of a real-life story. Maybe all of you who are sitting here are most likely our developers. You're sitting in a company and want to solve a problem, so by building a prototype first. So this is how you usually start to try something out, to figure out how things can do and go and work. And in this case, we are working for a car selling company and they need a service to promote their cars. So something totally fancy and completely real life, as you will see. So what do we start with? We need something which is, okay, a thing to, that represents our car. This hides here in, you see a bunch of modules already here, all in separate projects. Is it readable? Yeah, it should be readable quite nicely with the large screen. So we have a model where we have a representation of a car, so nothing fancy. In this case, I'm using EMF for such stuff. I will not go into details because this would be a talk of its own, but that you just see what we are talking about. We have a car which has an owner and has a type. So nothing fancy, nothing to write home about, which some generated code besides it, that we have objects we can work with. So next thing we have, we need something that can provide such a car, the information about such a car. For this, we have our service. And in that regard, fairly easy. We have two separate packages in here. One is the API package and one with an implementation in there. Also nothing really new. And we have this car service API, which gives us a car. So fancy is it, the whole thing. We see two things, and besides there, here we have the implementation of this car service. But first we see one thing if we slide back here. The tool tells us that this is something that is exported and available to the outside world. So, and whoever is working with this can also reference this package with a version. So we have this little package info Java next to it, where we have some annotations which one say, okay, this needs to be exported, and also this would be my version for the whole thing. I can later increment these versions and work with this, but when somebody requires this package and works with this package, then he can make sure that he gets the right and correct version. He knows his stuff works with. So, okay, then we know how the service should look from the outside and who people would work with, so how the interface is. And we have a little implementation for the whole thing. Most of the blue stuff are simple printouts. We don't really want to go into detail here, but it basically builds together a car, has some configuration in here with a default. If somebody asks, Trabant is an old East German car. And by default, it is owned by Max Mustermann for that. What we also see here, we have methods to activate, or which are called on activate and also on deactivate, because we have to take care about our life cycle. So when we get activated, so similar to usually you have a constructor, so there you can do your preparations. In this case, we create our object. We have, but that's usually it in Java. So when your object gets destroyed, if you're lucky, you have a system where you can have some pre-destroy methods or stuff like that. In our case, we have the deactivate method, and we are good little people, and we clean up behind us. Usually the garbage collector would do this, but quite often it makes sense to clean up what the mess you have produced. So now I have made my first little implementation at home for my prototype. I'm doing this over the weekend, so everybody can be happy at work when I show this how all these things work. And now we want to try it out. So thus, we need a little environment to run this thing in. So, and for that, I have here a little startup environment where we can start to orchestrate our system. So when I hit run, the whole thing, I have to find my console and make it larger. So we see that some stuff has happened. We see that too much has happened. Give me a second. So let's try that again, not with the end result. So we have a little system where we currently only have a console, which kind of is our interaction with our system in that case. Because everything we can show here is you always start on your IDE, you always start with one JVM. So and you should always build your stuff in a way that you can have it running in one place, because then it is easy to debug and easy to develop. So we can introspect our system here a little bit by looking inside, and it says, hey, these are the modules that are currently in here, so just the thing that provides this shell. So now we want to get started, and we take our, I want the mouse, give me a second. So, we have our car service here, and we see two things. We see two modules in here. So one is the car service API, and one is the car service impl. So how does that come? Because when we look in here, we just have one project. So this is also neat tooling. So I, as a developer, I'm usually lazy. I want to have things in one place. And thus, I just throw this into one project. But here I have a tool which can say, OK, I have an API and I have an implementation module, which should fall out of this whole shenanigans in here. And indeed, in here, we have two jar files that have been created. So now I say, OK, in my running system, I want my implementation in there. And this is everything which is actually required to do something. And then I can say, OK, resolve whatever else you need for the whole shenanigans. So you've seen before, we only had this few modules in there. We call them bundles in our case. And in order to run, we use EMF. So EMF needs to be in here. We need our model and also the API. So this is everything figured out by itself by the system because it looks at what we are using actually at runtime. So we hit update, and we see that nothing happens. OK, what has happened here? We might be confused. We look inside. Our stuff is in there. Everything says it's active or starting or stuff like that. But what's the issue now? So maybe look, what kind of services do we have in here? It says, oh, we have two services. One is active. This is something from the EMF part. And here we have our car service. So it says, OK, the service is satisfied, but nobody is using it because services, as you don't only have life cycles, they also can be demanded by somebody. And when nobody's there who needs the service, we don't need to start that service. We don't need to work with that. We don't need to take our resources for the whole thing. OK, so then let's get something where we can use the service. And we want to reach it from the outside, so a little REST endpoint would be nice for the whole thing. So I have here a little JAX-RS resource, which provides and works with the car service, if I use the correct thing. What can go wrong in live programming? So in here, we tell our system, we require the car service API or an implementation of the car service API, and then we want to return whatever car it gives us. So to just show the showcase. So we take what we have here, again, say, hey, we want the REST part in here, and hit resolve again, and let the system figure out the rest. So, and in our case, it figured out, oh, we need much more stuff. We need Jackson because we want to do serialization. Suddenly, we have stuff like the Jetty is suddenly in here so we can prograph. We have something that can provide us a REST environment where this thing can deploy it in. Looks great. So let's see what happens when we press update. Things happen. And an exception happens. Glorious. And this might happen because something is already running. So, and this is one of the things, when you do something, you should see immediate feedback. So it was not intended that way, but in the end, it helped us because it showed us, OK, we have some error here, because it could also be that you have something in your system already which takes up the port it wants to have here, which in our case we had. So this would require a restart. You could do it with some shenanigans in the background, but with some restart, it is it's easier to do and to accomplish in here. So now suddenly we see the same thing. OK, we have someone running here. OK, I had another session running in the background. Let's see what this session did. Because this obviously used already the thing. We have the whole thing running under car as a port 8081, car and rest. There was this little hello in there. And it says hello world. Okay, we have a REST endpoint. That's a good thing. Let's see if our car is available to us. Okay, our car is here. That's great. So this was now the work for of the weekend. On Monday we get back to work, present this to our boss and say, hey, I've built this little prototype which shows what we can do. The boss is happy and starts running around, basically selling your prototype. Usually, I guess this happened to everybody here in the room. You build a prototype, say this is just a demonstration. We need to really put work in and rewrite the whole thing. Business goes around and says, okay, we sell the prototype as a product. And this is what happens on first day. So you come back to work and they said, hey, we have sold your product. This is totally great. We only need some quick modifications to the whole thing. So currently you can just show one car. We want to show multiple cars to the world. Can you quickly do this and release the whole thing? It's a Tuesday. Always a good day to restart everything. So we do a little bit of modification. Right now we can only work with one car. So we put something in between, a so-called whiteboard. So a whiteboard is basically something which collects all the services around us for us and something we can interact with without knowing about all the pesky details of the service underneath it. So the whiteboard itself, also nothing fancy. We again have an interface. And in the implementation, we just say, give us all our services and add them together. And when somebody wants to know about all the cars, call the services, get the car for us, and hand this out to whoever wants this. This is what we want to use in our resource here. And because we are in a hurry, we are quickly doing this. And so we use this instead of that. Think, everything is done. Let's hit it and deploy it to the system and see what happens. And the system says, nope. So that's not good what you have done. Because what is it doing? It is telling us that something is missing. So it looks a little bit cryptic, but at least the system tells us before it does something. So, and what it does here is, it hasn't started our bundle because it was missing a dependency, because nobody put in the whiteboard in the currently running system. But our system is quite resilient. We now see we have a lot of services here, and somewhere in here we still have our car service, which is this one here. Which is still there. Somebody could still interact with the whole thing if it wanted to, but currently there's nobody there because the system that would interact with it would have isn't there at the moment. So we go here again, hit resolve again, and it finds suddenly that it also needs somewhere in here the whiteboard together with the API and the implementation for the whole thing, because without it, everything we do is useless. So we hit update. Something was happening, and hopefully by now, we see suddenly that we get a list here of cars. So everything is everybody's happy. You deploy the whole thing on Tuesday, go home and think, yes, that's it. Maybe as a side note, as a developer, I'm lazy. I had the dependency in my build path to the whiteboard in here beforehand. And I have lots of dependencies in here I usually don't use. But at runtime, the system only took what it really, really needed. Because the good tooling, in this case B&D tools, looks at what you're building, analyzes what you really use, and only provides this or names this as a requirement. This is something you quite often don't, you often don't find in the real world, because to quote Peter again, developers tend to not care about this. They package in everything, including the kitchen sink. So this is what you need to avoid, especially when you run a modular system. You don't want these transient dependencies clutter up whatever you are doing. So you don't need hundreds of megabytes if you only need 5 in the end. So yeah, we have been happy. We go back home. Suddenly a call from the DevOps team comes around. They need a health check for the whole thing. So we again take our laptop, develop another little module, call it the health check, which just is this one here. throw it in our system, try to test the whole thing. Say, okay, please do your thing. Suddenly something happens, so obviously something was deployed. And we now also have a thing which tells us something about our health. Hey, we're alive. That's great. So that was Friday. Monday, you come back to the office, think, now everything can cool down and everything will become relaxed. No, sales has been doing its job. New people want the whole thing. You need more information in there. You need more, as it usually is the case. They want more car services, and you start, oh God, should I implement a new car service for each car? Would be nice to do this just by configuration. Yeah, and good that we have a system that can take care of things like that. We have here this little configuration area where we say, hey, we have this little JSON which kind of configures our services. So we now get new services with people that own these things, plus our default, which is already in there. So this should stay in there. So okay, we again take the configuration. Somebody later can build something to make this with a nice UI that somebody can do it. But for now, this should do the job. So we throw in the configuration, say save again, say resolve again, say update, and suddenly things happen here. Oh, we see services are starting. And another service was going away. The default service has said, okay, I'm getting this post, and now I get services with configurations. So I have my cars in here. And if we look again, and reload this, we suddenly have more cars in here without doing any change to our code. Nice and neat little thing. So you thought, okay, I've saved the day again. Everything would be nice. Then they come around and say, yeah, but there is another customer who also wants to get his stuff in. And then you start thinking about, do I want to clutter up my system with more and more code, which is customer specific, but which is actually not what I intend to be for what I built initially? So maybe we should start distributing the whole thing a little bit. Put it in another container somewhere else running, and try to have the whole thing interact with each other. For that, I now would restart the whole thing, because we have something which is called remote services. So remote services basically make calls to any kind of service transparent to you. So, or intransparent, not sure. Also, you can basically call any service and you don't need to care where it is. Is it inside my VM or is it somewhere outside my VM? It doesn't really matter. So you always work similar to what you have done before. So I start my system, which is kind of the, oops, that's the wrong one. I start my, where was it? My system in this case with the ability to communicate with other stuff remotely. Right now it's basically the same thing as before. When it starts, it's Windows, so we have to be patient. So it kind of has the same thing. When we look at it, it still gives us the same stuff. It now just it now also gives us which container it comes from. It's just a system property I have in my launch configuration there. So this says, okay, that's the main one system, just for us to visualize the whole thing. The new customer also has a configuration, which is the customer configuration in this case. See it as a representation of an extra service somebody had programmed, something specific. So that's a fancy customer car, which needs to be added to the whole thing. And we have the second run configuration, which starts a second VM in our case. So usually we distribute it between systems. And the only thing we have in here is we have the configuration for how to do the remote communication. And we have our customer service configuration, service config for the customer, for the whole thing. So now if we start the second version here, we again wait. So something has happened. Let's see if our original container knows about the new car. So you see main, and suddenly here we have an additional car, which hasn't been there before, which you couldn't see because the screen wasn't large enough. Sorry for that. That's something I missed. And suddenly we started distributing the whole thing over different containers and started spreading everything out without too much hassle for the whole thing. So, okay, the week was great. So you have done your work, you go home. Monday you come back. They had been added again. And a new requirement comes around. And they say, yeah, we have a customer who wants to run the whole thing on his machine, but wants to communicate with our system, but has some special needs. We need an SDK for the whole thing. Okay, you sit there and think like, usually for most companies it's a headache to provide an SDK. Well, lucky us, we already took care of building stuff in a modular fashion, meaning we have a lot of different bundles, we have a lot of APIs people can work against, and we can decide which subset of these bundles will be necessary for the SDK, so they can develop their stuff and communicate with our system, without giving them all the internals and all the details for the whole thing. And in our case, we already published this with every build in our release here, where everything is, each time we build something, this is done by the Jenkins or whatever your build system is, it always releases the latest version of the whole thing. So now we go and have another IDE for the whole thing. This is what the customer can build. What they start with, they have our SDK in here as a remote repository. It currently links just to the other file folder over there. And they say, okay, yeah, what they want differently is they also want it via REST, but they want to have it as an XML, the whole thing. That's the main difference what they have. But they also want to use a whiteboard in there, and they want to see all the cars that we sell for the whole thing. So let's start the whole thing up and see what will happen here. So the only thing when we look inside here, besides the RSA stuff which is around, it just says, okay, we have a configuration for our REST, we have the configuration for a remote configuration, and we have the REST in here. And we have to skip something that it does not pull in. Yeah, we do it like that. So we want to tell the resolver, please don't pull in all the services we have. I think when I resolve it now, I break the whole system, so I just run what we have here. So 2 minutes left. Let's see what we have. The whole thing is running on a different port. And if we look in here, we suddenly see our stuff from the other containers running inside our system, plus something I've already accidentally deployed. And as we're running out of time, that's a good thing. We also see that there's a special one, that's this Maserati in here, which is not in the other system, but it's just for our system, because this is a special need which they can put in their thing. So they have a special implementation of the car service, which just puts together their special car and provides it inside the system without providing it to the other system. So in here, we don't find the Maserati. And in here, we have the Maserati in here. And now something fatal happens. Our original system crashes because we didn't take care of the whole thing. And we start by stop. This one, not sure which one I stop now. The fancy consumer should have been gone away. If we reload the other system, we see nothing. Okay, that's the demonstration effect. Yeah, not sure what happens now, but to conclude, was too much stuff anyway. Um, I showed you a lot of things, and I know it was a lot and it was kind of a mess, but what you've seen here is basically OCI in action together with BND and BND tools. What it can give you, it addresses all the problems we've talked about. It addresses versions, it addresses life cycles, it addresses dependencies in their trees. It helps you avoid bad design because it fails when you provide a bad design, so it does not make it impossible, but it still helps you. It's uniquely suitable for microservice environments because, as you can see, you can develop small stuff, distribute it as you like, and it's a proven and age-old standard. So we are hitting 25 years soon, so the whole thing is mature and the whole thing works. And thank you. Yeah, questions? I'm not sure if this works here. the questions.
I'm not sure. I think we're also, we have a red clock in front of us, so I think they'd like us to...
Vacate
Thank you,
stage.
everyone.
Yeah, thanks heaps.